Hi everyone, it's Linnea Tucker. This is a video tutorial covering CPM3 Module 1, Review Number 2. Okay, second review. So if you're on my roster, you should have a copy of this in your packet. If not, you can download it from the website that I gave you a link to, or just watch this. You can always do it on paper. Anyway, take out your vocabulary sheet because that's the first thing we're going to go over. All right, here's our vocabulary sheet. If you already got this filled out, you can advance the video. If at any time I'm going too fast, you are welcome to pause the video and even go back and go over something again. All right, number one, a mathematical statement that two expressions are equal is called an equation. Number two, a symbol used to represent a number is called a variable. Maybe you should fill out this whole sheet first and then see if you got them right. That'd be a great way to prepare for the test. Number three, in 2 to the third power, the 2 is called the base and the 3 is called the exponent. Number four, deciding what values of the variable make an equation true is called solving the equation. Number five, terms with the same variables raised to exactly the same powers are called like terms. 6, if terms are not like terms, then they are unlike terms. And you can only combine like terms. Number 7, the blank of a term is its numerical factor. That is called the numerical coefficient. Usually we just call it the coefficient, but it is a number. If there's no number there in front of your variable, then it's the invisible number 1. Number 8, a blank can be written in the form of ax plus b equals c. That's a linear equation in one variable. A, b, and c are all going to be numbers, so the only variable you have is x. Number 9, equations that have the same solution are called equivalent equations. Number 10, the solution of the equation x plus 5 equals x plus 5 is what? Now, if you subtract 5 from both sides, you get x equals x. If you subtract x from both sides, you get 5 equals 5. Both are true statements. So when this happens, you can use any number for the variable. So the solution is all real numbers. It can be positive, it can be negative, it can be zero, it can be fractions, it can be decimals, all the way out to positive and negative infinity. So all real numbers. The solutions to the equation x plus 5 equals x plus 4 is what? If you subtract x from both sides, you get 5 equals 4, and that's false. If you subtract, say, 5 from both sides, if you add x to both, if you subtract x from both sides, you get 5 equals 4, which is not true. And you're going to wind up with a not true statement. If you take a constant to one side, say you subtract 4 from both sides, you're going to get x plus 1 equals x, but then you're going to subtract x from both sides, and you're going to get 1 equals 0. So if you get a false statement that 10 equals 2 or 1 equals 0 and it's false, there is no solution. Okay? Number 12, an equation that describes a known relationship among quantities is called a formula. A blank can be written in the form of ax plus b is less than c, or using any of these other symbols. That's a linear inequality in one variable. 14, inequalities containing two inequality symbols are called compound inequalities. 15, if both sides of an inequality are multiplied or divided by the same positive number, the direction of the inequality symbol is the same. You don't change it. As opposed to number 16, if both sides of an inequality are multiplied or divided by the same negative number, the direction of the inequality is reversed. Yep. Okay, I think that's it for the vocabulary. All right, I want you to get out your calculators. I got a couple of things that I want to go over before we start the review. But you need to try this on your calculator. And I hope you've got that TI-30X. One person was told there's not a fraction button on the TI-30X. There is, and it looks like this. Okay, you're going to have to find it on your TI-30. Okay, take a look at these fractions. 6 over 8 reduces to 3 over 4. 6 and 8 are both divisible by 2. If you wind up with a fractional answer, you must reduce the fraction. The correct answer is always reduced. If you don't reduce it, you won't get full credit. Okay? 5/9 is 5/9. It won't reduce. 7 over 1 simplifies to what? If you put this in your calculator and you take 7 and divide by 1, you get what? Please do it now. Yeah, you get 7. 7 over 1 is not simplified. Now I want you to try this in your calculator. 0 divided by 4 gives you what? 0 divided by 4 is not simplified. 0 divided by 4 is what? Yeah, that's 0. 0 is your simplified answer. Okay, now in your calculator, I want you to try 4 divided by 0. 4 divided by 0. If you put that in your calculator, you get what? Yeah, you get an error. The only time that you'll be dividing by 0 is if you're calculating the slope of a vertical line. There is no run between points, so your run is 0. You're not going to write 4 divided by 0 is your slope, and you're not going to write error. You're going to write that the slope is undefined. Okay? All right. And then you can play with this button, and I can send out a video also that shows you how to use that fraction button on your calculator. I'm not a real pro at it because I never use that button. I know how to work with fractions. Okay, make sure you know your orders of operation. There is a problem on the test that is just simply orders of operation, which was talked about in CPM3, but some of you skipped that, so you do need to review your orders of operation. Orders of operation says you must do anything inside of grouping symbols first. Could be parentheses, brackets. This fraction bar is a grouping symbol. Then after you simplify that, then you simplify your exponents. After that, you'll simplify any division or multiplication that you find in order from left to right. And after that, you simplify subtraction and addition in order from left to right. Now with a fraction bar like this, you'll simplify your numerator, you'll simplify your denominator, and the last thing you'll do is take your numerator and divide by your denominator. Okay, so looking in the numerator, I see parentheses, but there's no math inside to simplify, so we're going to simplify the exponent first. So 2 squared means take the 2, the base, and multiply it by itself twice. So 2 times 2 is 4. Now in the numerator, what do we do next? Are we going to add or are we going to multiply? Yeah, you're going to multiply first. So that gives us 12 plus 12. In the denominator, I went ahead and took 6 and subtracted 12 and got negative 6. Let's continue to simplify the numerator. 12 plus 12 is 24. I don't know why that didn't pop up, but it's 24. And positive 24 divided by negative 6. Positive divided by negative is negative. 24 divided by 6 is 4. So it's negative 4. If I went too fast, you can slow down by hitting the pause button. Okay. Number 2, I think this is on review number 2. It says evaluate the expression. And there wasn't a problem like this on review 1. Well, for my students, I added it in. I think it's 5B. So if you didn't do it in lecture, I want you to go back and do 5B on review number 1. Absolute value bars. There's a problem where absolute value bars show up on the test, and we don't really talk about it in CPM3 because it was talked about in CPM2. Absolute value is the distance a number is from 0, and distance is always positive. Okay? So let's go ahead and drop in our numbers, and I'll talk more about absolute value. I'm going to put in a 3 for D, negative 5 for N, and negative 4 for P. And it looks like this. So orders of operations says simplify. Anything inside the parentheses you can simplify. Well, it's just a number, so we're done there. We're going to simplify this exponent here. 3 to the second power does not mean 3 times 2. It means 3 times 3. Okay? 3 times 3 is 9. Now let's multiply. Okay, I'm going to talk about absolute value first before I multiply. I told you absolute value is the distance from 0. So if I asked you how far away from 0 is the number 5, positive 5, you would say 5 units. If I asked you how far away from 0 is negative 5, you would say 5 units. They're both positive. Distance is always positive. So no matter whether I ask you for the absolute value of negative 5 or the absolute value of positive 5, the answer is both positive 5. All right? It does not change the sign. It makes the sign positive. So this right here simplifies to positive 5. All right? So we're adding a positive 5. Now multiply. Your 2 times 9 is 18. What is negative 4 times negative 4? That's positive 16. Finish adding. Did you get 39? Okay, good. Did you notice there's also an answer bank at the end of this review? So you can check yourself. Okay, number 4. Number 4 is a frequently missed question. So please pay attention to this one. Okay, is this, take a look at what we have, is this an expression or an equation? I know it's not an equation. Why? Right, there's no equal sign. If it was an equation with an equal sign, you would be able to solve for W, and at the end you would say W equals some number. Since this is not an equation, you cannot solve for W. The only thing you can do is simplify the expression. So we have to use distributive property first, okay? We're going to take the 3 times the W and get 3W. Then we're going to bring out that addition sign, and we're going to take 3 times 2 and get 6. The biggest mistake people make here is they forget to distribute this negative sign. The invisible number 1 is parked out front. So you could say, well, number 1, a negative 1 is being multiplied by both of these terms inside. So you're going to take negative 1 times 12. That'll become negative 12. And then you're going to take negative 1 times negative W. That's going to become a positive W. This right here is where everyone makes their error. They don't remember how to distribute a negative. Okay, so I parked a 1 there just so I have a number out front. I took 3 times W, and then I distributed the 3 to the 2 and got 6. Now I'm going to take -1 and multiply by 12. Then we distributed -1, multiplied that by -w. What is -1 times a positive 12? Yeah, that's -12. Or we're subtracting 12, it means the same thing. What is a -1 times a -w? What's negative times negative? Positive, and 1 times w is 1w. Now we can combine like terms. Okay, we've got 3 w's here plus 1 more w here makes 4 w's, and then 6 minus 12 is -6. So we've got 4w minus 6. That's all you can do with an expression, is just simplify it. All right, let's talk about the addition property of equality, the fact that it only works for equations and not for expressions. And notice what I'm about to show you here is not on the review sheet. It's just something I've added because I don't want you to make this error on the test. All right, can you find the error? The question was to simplify by combining like terms. Can you find the error? Pause the video, take a look at this. Okay, let's look and see what they've done here. It looks like first they distributed here and got 9r, and then they distributed here and got a plus 6, and then they distributed here, got -2, and then took -2 times -r. Negative times negative is positive 2r. All right, that step looks good. Then somebody saw this 2 here, -2, and they added 2. And then they added 2 here. Did you notice that was the error? They are thinking addition property of equality, but the addition property of equality only works when you have an equation. It only works if you have an equation. Let's say 9r plus 6 equals, I'm just going to make something up, 10. What you do to one side of the equation, you must do to the other. But this is not an equation and you don't have sides. Okay? You cannot do that if you don't have an equal sign. So they got 7r plus 8. Now if we do it the proper way, this step is still the same. You don't have an equal sign, so you're just combining like terms. You're going to combine 9r with a positive 2r and get 11r. And then you're going to take the 6 minus 2 and get plus 4. That's the correct answer. Okay? Aren't you glad you watched this video? Yeah. Okay, correct application of the addition property of equality. Equality implies equation. You must have an equation. Number 10 says solve the equation, check the solution. You can use the addition property of equality here. Look at the side where the variable's at. The first thing you want to get rid of on the side where the variable is any constants. Yeah, get rid of them. Let's get rid of subtraction by 16 by adding 16. And what you do to one side of an equation, you must do to the other. Okay? So we're going to add 16 to both sides. I get 8x equals 38. Now we're going to use multiplication property of equality. It implies a division. I can multiply this by 1/8 to get rid of it, but it's really dividing by 8. Let's divide 8 on both sides, and x equals 17. Now, if you've got time at the end of the test, what you want to do is you want to plug 17 back in right here, multiply by 8, subtract 16, and see if you don't get 120. Double checking your answers is a great way to get 100% on this test, on all tests. All right, solve this equation. This is a frequently missed question. There's going to be something like it on the test. All right, we've got two fractions and no one likes to deal with fractions. How can I eliminate the fractions and just deal with integers. Do you remember how? You could pause and look in your notes. You want to multiply both sides of the equation by the least common denominator between the 8 and the 2. Now the least common denominator is the smallest number that both of them divide evenly into. They both divide evenly into 16. It would work, but that's not your smallest. That's not your least. Can you think of another one? Yeah, they both divide evenly into 8. So let's use 8. I'm going to multiply both sides by 8. Don't forget to multiply the other side by 8. Now what happens here when you take this times this? I know a lot of people like to do that. You're going to have 8 over 1 times 3 over 8 times x. And when you multiply straight across, numerator times numerator, denominator times denominator, 24 divided by 8 is 3x. So we got rid of the fraction here. Let's bring down that minus sign. Now we're going to take 8 times 1/2. Well, what is 1/2 of 8? Yeah, you know it. Here, if you multiply straight across, you have 8 divided by 2, which gives you 4. We've totally gotten rid of the fractions, but now you've got to do that multiplication. 8 times 4 equals 32. Now you can solve for your variable. Now we don't have to deal with fractions. Okay? So here's the side where the variable's at. Get rid of that constant. How do you undo subtraction by 4? Now we're going to add 4 to both sides. So 32 plus 4 is 36. Now divide both sides by 3 and you get x equals 12. All right? If you got time at the end of the test, plug this back in for x right here. Multiply by 3/8. Do you know how to put 3/8 in your calculator? Not using the button. You know, I'm not a real good fraction button person. You would put in a parenthesis, 3 divided by 8, parenthesis. That's how I put a fraction into the calculator. And then multiply by 12. Or you don't even have to have the parentheses. Let's undo that. 8, parenthesis, multiply by 12. And hit enter. And then subtract 0.5 from it. You can convert that to a decimal. See if your answer isn't 4. I'll bet you it is. Okay. Substitute the given values into the formula and solve for the unknown variable. Round to the 10th place if necessary. I will send you guys out a video, short video on rounding. A lot of people will lose some points on rounding. We'll talk about that in a minute, but I'll send you out a video. Okay, I've got I equals PRT. This is the simple interest formula. They gave me I. I have a number for I, so I'm going to substitute that in here. They gave me a number for P. I'll substitute that in right there. And they gave me a number for R. I didn't pick a different color, did I? Here's R, so I'm going to substitute that in there. Guess which variable we're solving for? Yeah, we're solving for T. You can go ahead and solve for T if you want to. I equals PRT. These are all being multiplied together. If I'm solving for T, how do you get rid of multiplication by PR? Yeah, divide both sides by PR. These cancel each other out. You get T equals I over PR. And then you can plug your numbers in. Most people will just do this. Okay, my I comes first. 4485 equals, then my P comes next, 26,000 multiplied by R, 0.05 times T. And then the next thing they'll do is multiply those two together and then divide both sides by the answer. Well, that's what you're doing here. Here's P and here's R. After you multiply them together, you're going to divide both sides by the product of PR. Okay? And you get 3.45. Now, go back. It says round to the 10th place. This number right here is in the 10th place. With the decimal point, it goes tenths, hundredths, next is thousandths, 10,000ths. If we're rounding to the 10th place, the number in the hundredths place decides if the number in the 10th place stays as it is or goes up one. So if the next number over is 5 or greater, it forces this number to round up one. If it's less than 5, it stays the same. So here our final answer is what? Yeah, 3.5. And they didn't use units here, but it's going to be 3.5 years, I'm guessing. But if there's no units in the problem, you don't have to have units in the answer. If there is units in a word problem, you have to have units in your answer. Okay? Let's look at number 8. Oh, by the way, this is not on your review sheet, but it'd be really good if you guys would work this problem. Hint, hint. This should look familiar. It looks like something that came out of my math lab. Yes, it did. You really need to do a problem like this on your review. It says, recall that perimeter of a figure is the total distance around the figure. Given the right rectangle to the right, express the perimeter as an algebraic expression containing the variable x. Now remember, if you have an expression, you are not solving for the variable because you do not have an equation. You're just going to combine like terms. Okay, now perimeter is the distance all the way around, so let's add up all the sides. I have 5x minus 2, that's this side, plus the length of this side, that's plus 6x, plus this side here, which is 5x minus 2, plus this side here, which is 6x. You cannot set it equal to anything because they did not tell you what the perimeter is. The only thing you can do is what? Yeah, the only thing you can do here is combine like terms. I have 5x here, plus 6x here, plus 5x here, plus another 6x here. How many x's do you have altogether? 6 plus 6 is 12, plus another 10 gives you 22x. And then we're going to take a minus 2 and add it to another minus 2. That's minus 4. Now I want you guys to take a look. In my math lab, they always write in the units. Feet. You're going to have to write in your own units on the test. And if you don't, I'll deduct a point. So the answer here is in feet. That's the expression. That's the expression in terms of the variable x for the perimeter of this square. Okay, can you see the difference between an equation and an expression? In the expression, the equal sign went away. Did you see that? We have no equal sign. That's the difference. Here I actually use the formula for perimeter, 2 lengths plus 2 widths. You can do that also. 2 times 6x is going to be 12x. And here you will have to distribute. So that's 10x minus 4. 12x plus 10x is your 22x. Don't forget your feet. Yeah, that's part of your answer. Okay, here is a question that's not on the review sheet, but I want to go over it. It comes out of your homework, and there's something similar to this on the test. It says, in a mayoral election, can't say that, Jane Smith received 117 more votes than Jack Jones. If Jack received N votes, how many votes did Jane receive? And it says, type your answer in terms of N. They are looking for an expression that has an N in it. Okay? Now, let's go back and reread it a second time. It says Jane Smith received that many more votes than Jack Jones. She received 117 more, that implies addition, than Jack. If Jack received N votes, well, we're going to call the number that Jack received N. How many votes did Jane receive? Right there sets up your expression. It's 117 more than the number of votes that Jack received. And that is your answer expressed in terms of N. It's an expression. Okay? They defined this for you up here. If Jack received N votes. If Jack received N votes, then Jane received 117 more. Okay? Number 8 says, 6 less than twice a number is the same as 6 less than the number. Find the number. Okay, what is it that we don't know? Yeah, it's the number. So I want to define a variable. You can pick N or X or whatever. I said let X equal the number. Now we're going to go back through and read the sentence again. It says 6 less than twice a number. Well, twice a number is 2 times X. 6 less than twice the number. Is that 6 minus 2X? Or is that 2X minus 6? 6 less than twice the number. Your number, you're going to multiply by 2 and then subtract 6, so it's not this one. Be careful there. Is the same as, there's your equal sign. So equals the same as 6 less than the number. 6 less than the number, is that this? Or is that this? 6 less than the number means that it's going to be smaller by 6. So it's not that one. It's that. Okay? That's setting up your equation. Now you just have to solve for the variable. Okay, that's 6 less than twice the number is the same as 6 less than the number. When I've got variables on both sides of the equal sign, I move the variables first and the constants second. So here I want to subtract X. I don't want to subtract 2X from both sides because that'll make a negative X over here, and I don't want any more negative signs than what I have. So let's subtract. Oh, it doesn't do that. I'm going to subtract X from both sides. So 2X subtract 1X is X minus 6 equals negative 6. Okay? So here we're going to add 6, and X equals 0. Can X equal 0? Well, I guess it can. I mean, 0 is a number. Don't be afraid to use 0. It is a number. Okay, solve for A. We have C equals 2A plus 2B. Here's the variable I'm solving for. Is there an A in this second term? There isn't. So let's get rid of it first. Let's subtract 2B from both sides. So over here I have C subtract 2B. The only thing left on this side is 2A. Now I can solve for A by getting rid of multiplication by 2. Let's divide both sides by 2. Divide this side by 2. Divide this side by 2. And I get A equals C minus 2B in the numerator divided by 2. All right. Number 17 says, describe the solution set of the following graphs of inequalities using interval notation. Okay, well, when I look at this, I see, I'm just going to write it in as a regular inequality first, and then I'll change it to interval notation. This right here says -3, and it does not include 3. Since the arrow gets bigger than -3, this is x is greater than -3. Now, how do you write that in interval notation? Yeah, you've got a parenthesis here. It's parenthesis. My smallest number, if I'm going left to right, is -3, comma, then I get to the arrowhead, which means positive infinity, comma. Okay? On B, here I've got 4, and the numbers get smaller than 4, so it's all x's that are less than or equal to 4. In interval notation, if I grab my pen and I go left to right, the first thing I run into is an arrowhead. And that arrowhead is headed towards negative infinity. That's what goes in there first. Negative infinity with a parenthesis, comma, and then if I keep moving my pencil, the last thing I touch is 4 with the bracket. It includes the number 4. Okay, down here with C, this, written as an inequality, says all your x values here are less than or equal to 1, but at the same time they've got to be greater than -6. That's called a compound inequality. Now if we write the solution set in interval notation, it's pretty easy because they give you your symbols. Go small first, -6, move your pen to large, up to +1, bracket. Okay? All right. Let's just go over multiplication property of inequality again. This shows that if I multiply both sides by the same positive number, I still get a true statement. But what if I multiply both sides of the inequality by a negative number? I mean, we start off 2 is less than 6, and that's true. But if I multiply both sides by a negative, is -6 less than -18? No, -18 is farther to the left on the number line. That makes it smaller. It's no longer true. What do you have to do to make this statement true? You have to switch the inequality symbol. Okay, what if we're dividing? 2 is less than 6. If I divide both sides by the same positive number, I get 1 is less than 3, and that's true. What if I take 2 is less than 6 and divide both sides by the same negative number? +2 divided by -2 is -1. +6 divided by -2 is -3. Is -1 less than -3? No, -3 is farther to the left on the number line. It's smaller. So in order to make this statement true, I have to switch the sign. So anytime you multiply or divide by a negative, you have to switch the sign. All right, let's take a look at this one. Number 16 says, solve and graph the solution of the inequality, then write the answer in interval notation. Here's my variable. So on this side, I want to get rid of the constant first. The constant term is a +7. So let's subtract 7 from both sides, and I'm left with -3x equals 12. To get x by itself, I have to undo multiplication by -3. I'm going to divide both sides by -3. I'm dividing by a negative. What do I have to do with the symbol? Yeah, I have to switch it. Now I'm going to draw myself a number line. X is less than -4. -4 is right here. Since it's not equal to, I'm going to have a parenthesis with the arrowhead going such that all the solutions are less than -4. They're all getting smaller. If you solve an inequality and your variable winds up on the right-hand side of the statement, be careful, because some people think that this little guy right here points in the direction that you should put your arrow. But it doesn't. This says x, if you're reading backwards, it says x is less than -4. Switch it around because people are used to reading left to right. And that way you won't graph it wrong. Be careful. Now, the question is, how do you check yourself? How do you know you got the right answer? Take a number that you either know is going to be a solution or a number you know is not going to be a solution and plug it in for x. I know, looking at this, 0 should not be a solution. When I plug it in the way I have my graph drawn, it should be false. So if I put in 0 here, multiply by -3, that term drops out and I have 7 is greater than 19. That's false. I was expecting it to be false. I feel good about my number. You could put -10. That should make it true. If you take -3 times -10, you get +30. +30 plus 7 is 37. That's greater than 19, and that's true. So that's how you check yourself. Okay, oh, they wanted us to write the answer in interval notation. Always, when you think you're done, go back and reread the question so you don't miss a part. When I move my pencil left to right, first thing I encounter is the arrowhead. It's headed towards -infinity. I keep moving my pencil left to right. I get to -4 with a parenthesis. Okay, here is a problem. I don't know if it's on the review, but it's a frequently missed question. The question is find the number. It says the sum of 7 times a number and 2 is equal to 5 times the number. The thing we don't know is the number, so I'm going to let x represent the number. The sum of 7 times a number, there's 7 times a number, and 2, the sum of these two, the sum of 7 times the number and 2 is equal to 5 times the number. Where does the addition sign go? Yeah, right there. Now we're going to subtract 5x from both sides because I want to keep my variable positive. What is 5x subtract 5x? Yeah, it's 0. Don't be afraid to use 0. 0 is a number. Now I'm going to subtract 2 from both sides and divide both sides by 2. Okay? You can plug x of -1 back in here and make sure you get a true statement. Simplify this expression. This is number 3. Let's see here. I guess I moved this to the end because it's pretty easy to do. This is a like term with this one here. So we're going to take 0.2z and subtract 7.4z. Please use your calculator if you need to. I just moved the two together, and you can do that because of commutative property of addition. Combining like terms, you get -7.2z plus 4.6x. Because it's not an equation, you cannot solve for the variable. You can only simplify the expression. Okay, number 14 says Mandy is 5 inches taller than Melissa. If their combined height is 131, how tall are both girls? All right, well, the thing that I don't know, I need to set a variable equal to one or the other's heights. And in this problem, it's referencing Mandy's height in terms of Melissa. So Melissa is the variable. If Melissa is x inches tall, then what is Mandy's height? Yeah, Mandy's height is taller than Melissa. So, Mandy's height's going to be 5 inches taller than Melissa. It says if their combined height is 131 inches, If you're combining the two heights, what are you doing? Now we're going to add. So Mandy's height plus Melissa's height is 131. Is usually an equal sign in these word problems. So I'm going to take Mandy's height of 5 plus x plus Melissa's, set it equal to 131, and solve. I'm going to combine like terms, so I have 2x on the left-hand side. I'm going to subtract 5 from both sides, divide both sides by 2. So now Melissa's height is 163 what? Was it feet? Was it meters? Was it centimeters? Oh yeah, it was inches. And they want to know how tall are both girls. So Melissa is going to be 63 inches. Add 5 to that and you get 68 inches for Mandy. Why does that say years old? That should not say years old. I don't know where I got that from. We're talking height, so Mandy is 63 inches tall, and Melissa is 63 inches tall. How weird is that? I'm going to have to fix that. All right. Number 15, a 12-foot board is divided into 2 pieces so that one piece is twice as long as the other. If x represents the length of the shorter piece, find the length of each piece. Okay, it says we've got a 12-foot board, so I drew a diagram. It's cut into 2 pieces such that one piece is twice as long as the other. If x represents the length of the shorter piece, then this piece here is twice that length. How do you write your equation? Yeah, if you take the shorter piece plus the longer piece, that should equal 12 feet. There's your equation. Three, 2x plus x is 3x. Divide both sides by 3. And x equals 4 what? Yeah, 4 feet. So one board is 4 feet and the other board is twice that length. Plug it back into here. And the other one is 8 feet. And you can double check your answer. 4 feet plus 8 feet better add up to the total length of 12 feet. And it does. Okay, number 18. The sum of the first and fourth consecutive even integer is 202. Let x be the first even integer. Find all 4 integers. Is this on the review? Because I can't really remember. I might have thrown in some extra problems here just in case we had enough time. Anyway, let me show you. 2, 4, 6, and 8, those are all even integers. I'm going to let the x be the first even integer. Now, what's the relationship between 2 and 4? Now, 4 is 2 times bigger than 2, so 4 is x plus 2. Now, 6 in terms of the smallest integer is how much bigger? Yeah, that's 4 times bigger. But we really don't know that the first integer is 2, so we'll call it x plus 4. That's the next even integer. So this one's going to be what in terms of the first? Yeah, 8 is going to be 6 times bigger. But we don't know that the smallest number is 2. So this number here is x plus 6. Now, it says the sum of the first and the fourth consecutive even integer. The sum of the first and the fourth consecutive even integer is 202. So x plus 6 equals 202. There's your equation. And they want you to find all 4 integers. So let's solve for the smallest first. Let's combine like terms. Subtract 6 from both sides and divide by 2. X is 98. If x is 98 and it's the smallest and everything we're looking for is consecutive even integers, consecutive means one right after the other, then the next 3 numbers have to be, if the smallest is 98, it's 100, 102, and 104. All right? 104 is the smallest plus 6 more. Okay, number 9, graph this inequality. Z is less than or equal to 9 on a number line. Write the solution in interval notation. Z is less than or equal to 9, so that means we're going to have a bracket at 9, and everything less than it is a solution. So if I'm going to write my answer in interval notation, I start left to right with my pencil, and I touch an arrowhead, and that's pointed to negative infinity. So that's the first number with a parenthesis because you never get there. Keep moving your pencil left to right, and then you touch 9 with a bracket. And there's your answer in interval notation. Okay. Number 11, simplify by combining like terms. Like terms have the same variable in it raised to the same power. So those are like terms. And constants are like terms. So I've got 36x subtract 5x, which gives me 31x. And I've got negative 15 plus 13, which is negative 2. And that's your answer. You cannot solve for the variable. Why? Why can you not solve for the variable? Because there's no equal sign. Yeah, the only thing you can do is simplify, combine like terms. Number 12, solve for n. Here you want to get n by itself. You have to undo multiplication by negative 15. So we're going to divide both sides by negative 15. If you're not good with multiplying and dividing, adding and subtracting with positive and negative numbers, please use your calculator. Please use your calculator, double check. Negative divided by negative is positive, and 75 divided by 15 is 5. Okay. Number 5, solve the equation. Now I can see why I put this at the end. It's too easy. I want to get x by itself. How do you get rid of subtraction by 4? Yeah, you have to add 4, and what you do to one side, you must do to the other. So here, x is, now on your calculator, on these TI-30s, if you're going to put in negative 10, there is a button that looks like this, and it has a little dash in it, and it's towards the bottom. That's your negative number. You're not going to use the button over here that's the subtraction. You're going to use the button that looks like this to put in negative 10, and then add 4 and hit enter. And you get negative 6. Exponents review. I'm not going to say anything here. You can stop the video and take a look at it. Just a little review so you remember, you know, what we're doing with exponents. Stop the video and take a look. Take a look at this, because where you have your negative sign and whether or not you have parentheses is important. Your base here is negative 2, and that exponent of 2 says you're going to multiply negative 2 by itself twice. Negative times negative is positive. If you have negative 2 and it's in parentheses and it's raised to the third power, it says take negative 2 and multiply it by itself 3 times. Negative times negative is positive, and a positive times negative is negative. And you can do this in your calculator also. To enter this in the calculator, you hit that negative button. Okay? Oh, and put in a parenthesis first with the negative button, then hit 2 with another parenthesis. There's a button on your calculator that looks like this. That's your power button. And then put in 3 and hit your enter button. Your answer should be negative 8. Give that a try. Okay, so just take a look at this. You're probably seeing a pattern here. Now take a look at this. Here negative 2 is not in parentheses. That exponent of 2 only applies to the 2, but not the negative sign. It's like multiplying 2 by -1. And here the 2 only apply, that exponent of 2 only applies to the base of 2. So 2 squared is 2 times 2, which is 4. And 4 times -1 is -4. You've got to be careful if there's a parenthesis involved or if there's not, because it makes a difference. Take a look at these. Do you notice the difference? Okay, this was the first page with the base inside parentheses. Here's the second page where there are no parentheses, so your base is just the 2 but not the negative sign. All right, be careful. Okay, and here's just a compare and contrast, which is what we just did. So pause the video and take a look at this page. Okay, evaluate expressions. Pause the video, take a look at this page. Try to do these in your calculator also. If you did this in your calculator, it would be 3, your power button, 4 is your exponent, and enter. See if you get this for your answer. What's your answer here? What's your answer here? What's your answer here? Here you're actually going to do your orders of operation. You do have math you can simplify inside the parentheses, so do that first. Well, I would have done it first. I would have called that 8 raised to the 3rd power, but I'm just showing you here what raising something to the 3rd power actually means. Multiply it by itself 3 times. Which do you do first here? Do you take 3 times 4, or do you take 4 and square it first? Orders of operation says grouping symbols, then exponents. You're going to take 4 and square it first, and then multiply by 3. Don't take 3 times 4, you're going to get a totally different answer. Okay? These ones here, I'm just going to click through them. If you would like to, I would stop the problem when the statement comes up, work it on notebook paper, and we'll compare answers. But from here on, I'm not going to talk. I'm just going to pop them up, give you time to pause the video, and then do the problem, then check. Well, it might be worth looking at that one. That's true. What's your answer? And that's true. What's your answer? All real numbers. You guys know your textbook's online.